It might be a little bit less detailed than chemistry, but this is something that you do in chemistry a lot. We're just gonna spend one day on it, okay? So, there are digits in measurements that are called significant. And what we're gonna do today is learn how do we tell in a measurement if numbers are significant or not. It's like if I told you I measured something and it was 12.25. Are all of those numbers precise? And if they are, we say they are significant, okay? So what we're gonna do today is we're gonna learn rules of how to tell if those numbers are significant or not. Some books, chemistry, you learn this more in chemistry than in math, but our book has it. But some books call it significant digits, some call it significant figures. Okay? And some books or teachers, a lot of science teachers call it sig figs. So if you hear me say sig figs, I actually have a chemistry major and I used to teach chemistry. If you hear me say sig figs, that's the same as significant digits, okay? All right, so the first rule for telling if a number is significant or not is that any digit that is not 0 is considered significant. So the only one you ever have to worry about is if you have a 0. So if I look here, all 3 of these are non-zero digits and all of them are significant, so your answer would just be 3. Any digit that's not 0 is automatically significant, okay? Now, the second rule is what if you have a number such as 2007 where you have zeros in between 2 numbers that are not 0. When you have that, if those zeros are in between 2 numbers that are not 0, these become significant. So if your end numbers are not 0, all of these become significant. So like this one would be 1, 2, 3, 4, 5, 6, 7. And this one, because these zeros are in between 2 numbers that are not 0, they're significant also. So this would be 1, 2, 3, 4. Does that make sense? So if zeros are in between 2 numbers that are not 0, you count them all. Okay? Now, the next rule is, what if you have a large number that has a bunch of zeros that really these zeros are there just for placeholders to make this number large? So what happens if we have a situation like that? If you have a really large number where you have a bunch of zeros that are there just to make that number big, we do not count these zeros. So we would only count the 5 and the 2, and this would have 2 sig figs, okay? So if you had something like 1,250,000 like that, what do you think that one would be? How many sig figs would it be? 3, yeah. Just the 1, 2, and 5, okay? Now, what do you think about this? What if I had 1, 2, 5, 0, 0, 0, 1? What do you think about that? Do you think you would count all of them then? Yes, because these zeros are in between 2 numbers that are not 0, so we count all of them. So this would be 1, 2, 3, 4, 5, 6, 7. Okay? All right, if I go down here, another way that we have a lot of zeros is if we have an extremely small number where we have zeros that are there just for placeholders to make this number small, okay? This 0, we usually don't write, so I just kind of ignore that 0 and don't even worry about it. But these 3 zeros right there are there just for placeholders to make that a really small number. We don't count them then. So we only count this as 1, 2. It would have 2 sig figs, okay? So if you had something like 0.000025, do you get that these would not be counted? Everybody understand that? You would not count those. And we would only count the 2 and the 5. So we would only have a 2 for that one, okay? So whenever we have placeholders that make a number super large or make a number super small, then we don't count those zeros. But here's where it gets tricky. If I said to you guys, our number is 1.000025, do you know how now these zeros are in between 2 non-zero numbers? That rule trumps the one where those are just there for placeholders. So if these zeros are in between 2 non-zeros, we do count them. So this would be 1, 2, 3, 4, 5, 6, 7. Okay, now let's look here. It says if zeros are trailing zeros after a decimal, they are significant. So this is what that means. If I gave you guys a measurement that was 2.560, okay? 2.560. This 0 here is saying that it's accurate or precise to one more measurement, and then we count that 0 as it is significant. Even if you had 2 zeros there, that means that you've measured that 2 more places, and we count both of these. When you have zeros at the end of a decimal, they are called trailing zeros, and we count them, okay? So if you had something like 0.001250, what do you guys think that would be? Do you think I would count these 3? No. Do I count that one? Yeah, because it's a trailing 0, right? So do you guys get it would be 4? What if I changed it and I put a 1 there? Then what? Then do I have to count them all? Right? Okay, perfect. So let's try to go over some examples and see if you get it. So, what do you guys think about the first one? Do we count these 3 at the end? No, those are there for place values. So do you get that one would be 3? Okay. What do you think about these 3? Do we count those? Yes. So how many would we have? 5. And do you guys get the reason we count those is because they're in between 2 numbers that are not 0? Okay. Let's look down at C. We have kind of 2 different scenarios going on. What about those 3? Do we count them? Yeah, because they're in between 2 non-zeros. Do we count these 2? Yes, because they're trailing zeros. There's zeros after a non-zero number in a decimal. So you do count those. So we're going to count everything. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. What do we think about D? Do we count these 3? Yes. So we would have how many? 6, right? We would count all of them. Now if I look at E, do I count those 3? No. Do I count this one? Yes, so it's 3, correct? All right, how about F? Do I count these 2? Okay, and that would be 5. So we count all of them. When I look at the next one, do I count those 2? Because they're in between 2 non-zeroed numbers, do I count this one? Yes, because it's a trailing 0. So that one would be 5. Then if we look at this last one, do I count these? No. Do I count these? Yes. So do you get it would be 1, 2, 3, 4? Okay. Now your assignment is going to be different. Trying to think how I'm going to show you this. It'll just take me a second to figure it out. I don't think I'm going to give you worksheets. So just give me a second to figure out what I'm going to give you for the assignment. Okay? Okay, so I'm going to give you a worksheet, and then I'm also going to give you a review assignment. So I just want to look at what that is. Sorry, I kind of switched things up and I didn't make changes on here. Okay, so I'm going to give you a worksheet, and then I'm going to give you a review assignment, and I just want to make sure that I've taught all of this before I give it. Okay, so I'm going to give you the worksheet and then these problems.